Hi everyone, once again welcome to the LPS course. This lecture we are continuing to look at the Python programs. We covered 6 of them. Today we are going to cover the remaining ones. So I'm going to go quickly over these things basically so that you get an idea of how the Python code is written and what are the benefits of the Python code. Once again, Python is used for pretty much like it's a scripting, but at the same time you get the full power of a programming language. So here we are actually like going to the number 7, which is the programs on lists essentially. So here the first one is just a simple function which is given a list of numbers. We return a list where all the adjacent elements have been reduced to a single element. This is the adjacent equivalent elements. So if it is 1, 2, 2, 3, the program returns 1, 2, 3 as a list. So here we define this function, remove adjacent, and then basically it's a list of numbers, and then the result is also a list. So we define as an empty list initially, and then we basically say like if for each of these elements inside this num, so there is num in nums. Now if length result equal to 0 or num is not equal to result minus 1, then we append result minus append result. We use this particular method, that is append, with the number. So here you can see basically like the length of result is 0. That means that it is a starting point, which right now it is 0, and then if the number is not equal to the result minus minus 1, that means that the last element, then we append it. Otherwise we don't append, we just continue, and then until all these numbers are exhausted, and then we return the result as the list. So simple program. Just look at the way that it is written, how elegant it is. All we do is essentially like this method which is called append. That's what we are using it here. So another one is basically given 2 lists sorted in increasing order. Create and return a merged list of all elements in sorted order. You may modify the passed in lists. Ideally the solution should work in linear time. So what that means is basically for every element it needs to take a fixed amount of time, so that it is not an exponential or anything else like that. So we need to do only one pass for both the lists. So here we define the same function like a linear merge, list 1 and list 2. Those are the 2 input ones that we are giving here, and then we define a new one called result list, and that is defined as an empty list up front. So then now we are going to do basically for we look at the 2 lists so long as both are non-empty, take whichever element is the smaller. So that's the whole overall algorithm that is in this comments. I can see that. So while these 2 lists are non-zero. Now what we do is basically like if list 1's 0 is less than list 2's 0, then we append as list 1 basically, and then what we do is basically like then that's actually removed from the list. Whichever one gets appended, that gets removed from the list. And if it is the other one, then we append the second one and then remove that from the list. Now we track what is left by using result.extend. list 1 and same list 2, and then we basically return the list, the result itself. Again, it's a fairly simple program to write. Just keep in mind about this. Here what we do is basically like whichever one is smaller, we put it in the result list and then pop it out of the original list. So now a test function used in main to print what each function returns versus what it is supposed to return. This is our standard one that we know basically. So if God is equal to expected, then prefix is okay, otherwise prefix is X, and then we print the whole thing. So now we test all these programs basically. So the remove adjacent we just give like 1 2 2 3, and then we expect the result to be 1 2 3. And then we also try it with some other things, basically 2 2 3 3 3 should be just 2 3, and then if it is an empty list, it should print an empty list. And then for the linear merge, we again do like a couple of conditions. One is we do AAXX ZZ and BBCC, and then the BBCC should be in the middle of that. And then if it is AAXX and then BBCC ZZ, then the BB and CC should be middle, and then Z should be at the end. And then AA and then AA BB BB should be like 3 AAs and then 2 BBs. So here is what we get when we run these programs, and we can say that actually it has executed successfully. So this is one way to actually test these kind of programs. I think you should be aware of this, and you should be using these kind of testing before you submit any of the programs in an assignment. Now let's look at some of the programs for string. Again, we will go through the similar kind of testing procedure. So let's see what kind of things that we can do. The number one is donuts, basically, which is given an integer count of a number of donuts, return a string in the form of number of donuts, the count, where count is a number passed in. However, if the count is 10 or more, then use the word many instead of the actual count. So if donuts 5 returns number of donuts is 5, but if donuts 23 returns number of donuts many. So how do we do that? So here we again define the our function called donuts, and then we pass the counts as the input, and if the count is less than 10, then we return the number of donuts is plus, so number of donuts colon, and then we print this string count, which is essentially like whatever the number that is less than 10. Else we just return number of donuts and many. So basically, like this is a very short program to test to do what we wanted. Now the next one is basically both ends is another function. Here essentially, like if length of this string is less than 2, then return nothing. The first 2 is basically like the strings the 2 values, and then the last 2 is actually strings -2 colon, basically that specifies the last 2, and then we return the first 2 and the last 2. Okay, so this is basically it returns the 2 characters at both ends of the string. Now a fixed start, essentially this is given a string S, return a string where all occurrences of the first character have been changed to star, except do not change the first character itself. So if it is a Babel, that will become BA star star LE. So the solution is here basically, which is we get the string S, and then we define what is the front, which is S0, and what is the back, which is S minus 1, and then we say, like, I mean, fixed back, which is we use this method back dot replace essentially, and that we with so this gives you the rest of the characters essentially. One column rest is basically like all the ones that are after the first one. The first one we already captured in the form, and then so once you want to fix that this back, basically we replace the front, which is this character, with the star. So that replaces all the remaining occurrences of this front character with the star, and then we just return front and the fixed back. I think these are fairly easy. I think you should be able to understand most of the stuff. I'll still go through some of these things. So here the mix-up, basically given strings A and B, return a single string with A and B separated by space, that is A B, except the swap the first two characters of each of the strings. So mix pod will become fox mid, or dog dinner will become dig donner. So we define again the function mixup AB, and then essentially like we define the A swapped is B, the first two column, plus A 2 onwards the remaining, and then the swapped is same thing basically, A's first two characters and then the remaining of the B, and then we simply basically return the A swapped, then a space, and then B swapped. Now again same function that we defined basically, and then here this is for testing these the above functions, and then we define the main as basically like what is the function call with what should be the return value. And when we test these different functions, essentially like all these 4 functions, we get the following output, which is confirms that we have written the code correctly. So now more programs on string. Here basically it is called the verbing, which is given a string, if its length is at least 3, add ing to the end, unless it already ends in ing, in which case add ly instead. If the string length is less than 3, leave it unchanged and return the resulting string. So here is the our little function which takes s as the input string. Now we first of all we see whether the length is less than or equal to 3. If that is there, sorry, if it is greater than or equal to 3. So if it is there, then we try to see whether the last 3 characters are ing, which is s minus 3 colon, and if it is not ing, then we add the ing to the end. But if it is ing, which goes into the else, now we add ly as a string and append that to the original string, and then we return the s. So in this case, if it is less than 3, it basically like leaves it as is. Now the next function is not bad, which is given a string, find the first appearance of the substring not and bad. If bad follows the not, then replace the whole not bad substring with good. Return the resulting string. So if it is basically like says like dinner is not that bad, then you get dinner is good basically. So it's a not that and bad, or anything that is in between not and bad is basically replaced with this good. So the way that we write it is basically, again, we get the string, then we find not, so this is a method, and we also find bad, store it in these two variables n and b, and then if they are not the last characters, last ones essentially, which is n not equal to 1 or b not equal to 1, and if b is greater than n, then we look at the string and then essentially replace the last the n character essentially. So we take out the characters up to n and put the good there, and then the remaining basically, so and b plus 3. So that means that essentially we continue after the bad. So we go up to not, print good, and then go after the bad. So this prints the whole new string. So most of these kind of algorithms are self-explanatory. I will go through it, but I think, like, I mean, once you read it, it will be fairly easy for you to understand how these algorithms are written. And then, as you can see, like, I mean, these are all like less than 10 lines of code, so you should be able to pick it up very easily. Okay. So the next one is front back basically, which is dividing a string into two halves. If the length is even, then the front and the back halves are the same length. If the length is odd, then we will say that an extra character goes in the front half. That is A, B, C, D, E. The front half is A, B, C, and the back half is D, E. The given two strings A and B, we return a string in the form of A front, B front, and then A back, B back. So we take these two strings basically A and B, and now we need to figure out the middle position of each string. So A middle is length A divided by 2, and B middle is length B divided by 2. Now we see whether it's an even or an odd. If this is odd, now add 1 to the length. 1 if the length is odd, and then so we add that basically A middle plus 1. If it is if the same thing goes for the B also. So you see basically, like, when we divide by 2, we don't put the decimal, so that it is an integer division and it is a lower number. So that's why we are just adding 1 to it. If you use like .0 or something here, then that will mess up the whole calculation. So please don't do that. And then finally we return basically the A string from 0 all the way to A middle, and then B string with 0 all the way to B middle. and then A string, A middle all the way to the end, and then B middle all the way to the end. So again we do the testing program and then test it, and here we see that basically everything is correct. So this is the example program on game. This is probably the last one. Here first we say basically the high score for the game, which is 0, and now we do a try basically like coming with high score dot text essentially, and then so basically there's already exceptions built in into this one, the try catch. So we try to read the high score from this file. That's the whole intent. So whether we just read that high score and then we close that file, and then we print the high score is so basically, and then we generate any exceptions. And then we try to get the score from the current game, which is current score is 0, and then we ask the user for her score, and then again we have an exception handler if it is typed something else. And then if current score is greater than the high score, then we say like, yeah, you got a new score, and then we also open the thing and then write out the new score into the file. And then if it is not there, then just say like print better luck next time. So here this is one thing that how the program does. So that's pretty much all that I want to cover for today. I hope like the Python programming is quite enjoyable. With these kind of snippets, you can actually build bigger programs very easily, and I would like you to try those kind of things. And these are all like some basic programs which from which you can build bigger and better programs. Thank you very much. Okay. Bye.